guys, welcome back to the channel. It's your boy Julien Stoutt, licensed personal trainer, licensed PE teacher, world record powerlifter, special education teacher, here to take the fear out of fitness. We're about to take off and class is in session, guys. Terribly sorry for the delay. We had some technical difficulties, had some updates on the computer. Things got a little wonky, had to figure it out. So actually, I didn't even know it was going to do that. I thought it was just going to be the way I left it. But as we know, technology is not what it once was, so it is what it is. But I am here now, and I have the topic to talk about. Okay. If you're watching, those of you who know me knows that I'm an advocate for HIV research. I'm an advocate of HIV and AIDS care, also HIV and AIDS education. As somebody who has been at the forefront of this since 1993, 92 actually. Since I've been at the forefront of this since 1992, one of the things that many of you don't know, if you're under the age of a particular age, I'd even say if you're under the age of, let's say, 35, you don't know the horror that is HIV and AIDS. HIV and AIDS took the lives of two teachers that I cared for deeply, respected greatly, and I watched and witnessed a cascade of celebrities fall by the wayside due to this horrendous disease. The simple fact that Magic Johnson is still walking, breathing, and talking and thriving is a medical miracle. 34 years in the making. When Magic Johnson announced that he had HIV and he needed to subsequently retire from the NBA effective immediately, the world stopped. Whether you're just an LA Lakers fan, whether you're a sports fan, whether you are just fan of celebrity, when Magic Johnson made that announcement, that floored everybody. And it put a new face to HIV. 99 times out of 10, when somebody contracted the HIV virus, many people merely assumed you lived an alternate lifestyle. And in living that alternate lifestyle, this is how you contracted the disease. And it wasn't true. As a matter of fact, getting involved in it, you immediately knew it wasn't true because people like Arthur Ashe contracted it. Ryan White contracted it. People who were thriving human beings initially and did not have this disease, was not into any drugs or quote unquote homosexual activities, because you have to understand that at that time it was hitting the LGBTQ community especially hard. And then all of a sudden heterosexuals were finding themselves getting it through two ways. That would be engaging in unprotected sexual activity with somebody at that time was believed to be bisexual, or they themselves, the person was into intravenous drug use and therefore transmitted it to another heterosexual partner that way, meaning they sexually transmitted it even though they weren't living that lifestyle. So I'm not saying anything untowards because it's just the way it was. Okay. Now it can happen to anybody. It has been happening to anybody. And I have my theories on all of this, and I'm not going to share it with you. Those of you who know me know what it is. But ultimately, you guys have to understand where we've been to where we are now. And where we are now is potentially the end of the HIV/AIDS epidemic. And I'm going to share my screen with you. Okay. A CRISPR-Cas cure for HIV/AIDS. HIV infections and HIV-induced acquired immunodeficiency syndrome continue to represent a global health burden. There is currently no effective vaccine nor any cure for HIV infections. Existing antiretroviral therapy can suppress viral replication, but only as long as antiviral drugs are taken. HIV infects cells of the host immune system and can establish a long-lived viral reservoir which can be targeted and edited through gene therapy. Gene editing platforms based on the clustered regularly interspaced palindromic repeat CAS system, which is what CRISPR-Cas stands for, has been recognized as promising tools in the development of gene therapies for HIV infections. In this review, we evaluate the current landscape of CRISPR-Cas based therapies against HIV with an emphasis on the infection biology of the virus as well as the activity of host restriction factors. We discuss the potential of combined CRISPR-Cas approach that targets host and viral genes to activate antiviral host factors and inhibit viral replication simultaneously. So what they're doing is they're attacking it from two different ends. Lastly, we focus on the challenges and potential solutions of CRISPR-Cas gene editing approaches in achieving an HIV cure. So going back, I'm going to skip a couple of lines here, but we're going to keep going. Combination antiretroviral therapy, or CART, the current golden standard treatment for HIV infections, is effective in controlling viral replication. CART is based on a straightforward principle of targeting and inhibiting different stages of the viral replication cycle, to prevent viral escape. So for those of y'all who don't know, let me stop there. For those of y'all who don't know, HIV has a unique way of getting into our system and doing damage. What it does is it gets into our white blood cell factories by mimicking a white blood cell. And by mimicking that white blood cell, they take over those factories and then they replicate themselves in it, and thus destroying the factory where our T cells are made. As a result, the virus spreads, body never recognizes it because it replicates mimicking white blood cells. And in doing so, what happens is you end up with a compromised immune system. Now, foreign agents that normally your body would have immediately destroyed and fought off, all of a sudden becomes easier times of infection and easier times of causing serious bodily harm, which then therefore causes your demise. Okay? So what they're saying is this CART system that they're using right now actually stops and slows down the replication process to the point where it replicates at a point where it's almost non-existent. That is where the terminology HIV non-detectable comes from, because you're not HIV negative, you're HIV non-detectable, meaning you create so little of the strand that current tests do not pick up the virus. But it does not mean you are free from the virus. A major obstacle for HIV therapies, including CART, is the presence of long-lived and poorly understood HIV reservoirs. These are cells that were once infected by replication-competent viruses, mainly CD4 positive T cells, in which the HIV genome, mind you, I did not read this ahead of time, in which the HIV genome integrates into the cellular genome as a stable source for new viruses. These cells can persist over extended times. At any time, cells in the latent reservoir can become activated to start virus production, which can reignite virus replication once therapy has stopped. And then also they become extra resistant to the therapy if you do fail to take your medication. Hence, the search for HIV cure goes hand in hand with the development of strategies that trigger the eradication of viral reservoirs. Besides antiviral drugs, alternative methods such as gene editing shows encouraging results and may achieve a functional HIV cure by inactivating the integrated HIV DNA. One of the most promising gene editing strategies is the clustered regularly interspaced palindromic repeat CAS platform. The CRISPR-Cas system was first identified in prokaryotes as an immune response mechanism against bacteriophage infections and invading plasmids. In simple terms, the CRISPR-Cas system contains a nuclease named CAS or Cas, which binds to the short CRISPR RNA that targets complementary viral DNA or RNA sequences, depending on the type of CRISPR-Cas system. The Cas9 and Cas12 endonucleases cleave the DNA, while the Cas13 enzyme cleaves the RNA. CRISPR-Cas offers a simple and efficient manner of the site-specific mutation of genomes in a wide variety of organisms. Successful targeting requires a sequence complementary between the cRNA and the target gene. Most CRISPR-Cas systems employ a short critical 2 to 6 nucleotide sequence flanking the target that is named the protospacer adjacent motif, or PAM, for Cas9/12, and a protospacer flanking site, PFS, for the Cas13. So here is how the Cas9 works, the Cas12 works, and the Cas13 works. DNA and RNA targeting CRISPR-Cas systems different CRISPR-Cas proteins 9, 12, and 13, their target molecules and the cleavage mechanisms that they employ are schematically depicted. So again, we're going to go right here. It's at this juncture right here in which it is here in which the cleaving of the HIV DNA happens. One happens here, the other one happens a little further inward, creating that space to where it cleaves and disintegrates the DNA. Whereas the Cas13 actually works at the RNA level, disintegrating or degrading the RNA of the HIV virus itself. The prospacer Jason motive, or the PAM required for the CAS9 and 12 cleavage, in addition to the protospacer flanking site required for some CAS13 orthologs, are in the pink. The cRNAs are depicted in red for each CRISPR-Cas system. When the double-strand DNA breaks are created by the Cas9 and Cas12 cellular DNA repair mechanisms are induced. Either non-homologous end joinings or homology-directed repair, HDR, requires a donor DNA template and can result in precise gene editing. While NHEJ is an error-prone repair process that introduces mutations, insertions, and deletions, shown in orange. The Cas13 recognition and cleavage of the target RNA transcript leads to its degradation and possibly the non-specific degradation of nearby transcripts. So in essence, what it's saying is that it's targeting certain helixes inside the DNA, or it is attacking a portion of the helix in the RNA and completely disintegrating the virus from a RNA or DNA level. Catalytically, CAS9 and 12 nucleuses cut both strands of the double-strand DNA, like I just said, producing blunt and staggered ends, respectively, and thereby activate cellular DNA repair mechanisms. So in other words, breaks down the DNA and then forces you to regenerate the DNA, but not in the form that it once was infected with HIV. In the absence of a donor template, DNA ends are repaired by an error-prone mechanism named the non-homogeneous end joining, or the NHEJ. NHEJ typically leads to nucleotide insertions and deletions, but sometimes also substitutions. That's right, I was going to say substrations, but okay, substitution around the cleavage site in the protein coding part of the gene. Indels may shift the open reading frame. CRISPR-Cas-based strategies have been applied as direct antivirals by mutating or excising the integrated proviral HIV DNA, or indirectly by disabling viral receptors for cell entry. So in other words, it either destroys the DNA or it cleaves the RNA away from cellular sites so that way it cannot replicate. Now, I don't know about you, but me, I am excited by this, because what that means is either they destroy the DNA to where HIV resides, and then your body has to go in and figure out how to fix it, or it completely runs in, essentially from on a micro level, not even microscopic, but deeper than microscopic level, I would even go nanoscopic level, and cleaves HIV off of hosting cells and then basically bleaches it. And when I say bleach, I know it's not bleach. So please, YouTube airwaves, do not cut me off, because I'm not suggesting that HIV is being dealt with bleach. I am saying that essentially the CRISPR-Cas system 13 specifically actually comes in and molecularly breaks up the RNA off of cells, that then causes the lack of production places for HIV to reign, which therefore essentially means your body will eradicate the virus out of your body, because it has no place to integrate itself and then replicate. Because it has no place to integrate, it cannot replicate. Therefore, it will essentially become eradicated. All right. Now, we are 33 years removed from the first HIV/AIDS peer education program that was once started by the late, great Mr. Thomas Porton. I really wish he was here to see this. Shout out to Liz Ruffin. Liz, I know if you happen to come across this video at any point in time, first of all, thank you for educating me and my classmates on how HIV works. And thank you for educating me and my classmates about how we can educate others on how it works, that it is not a gay disease. It is not a quote unquote sin from God. That's not what it is. It's not a punishment from God, I should say. It was a disease that just happened to hurt millions of people. Without your knowledge and your education on the subject matter, I don't know if I would have ever gotten to be as informed about HIV as I have been. I'm really glad. I'm truly glad that we have found ourselves in a place now that we can officially say we are at the near tail end of this godforsaken disease. Obviously, they have not fully done this in clinical trials yet, but as a matter of fact, excuse me for a second. Basically, at this point, they have not done clinical trials yet. But obviously, in their works, in their collection of data, they are showing that they have the potential to actually do it. Now, what I am fearful of, personally, this is my opinion, I'm not saying it is, so do not come for me for this. My only concern is that the medication or the therapy or the process of eradicating HIV from the system, utilizing the CRISPR-Cas system, could potentially harm thriving, healthy DNA. Okay? Now, if that means it's temporary and it's a minor setback that you'll right yourself once you've gone through the therapy, hey, it's better than the alternative. Or you could just live with it and take your antiretroviral medication. Either way, I'm fine. Right now, we have actors like Charlie Sheen, who has HIV, non-detectable, but he has HIV. Magic Johnson's at the same state. Dozens, hundreds of thousands, if not millions of people are in that same state. I have to say that we are truly in remarkable times. The great Chris Rock once said that they're not going to cure HIV. They're going to find the medicine for it. And so far they have. So the thing is, I'm landing this plane now, sorry. But the thing is, now more than ever, the need to cure diseases is now at hand. Nobody wants to live with a disease of any kind. From herpes to hepatitis to HIV, nobody wants to live with a disease. What we are doing now in our research is highly promising, but the climate that we're in right now, when it comes to research and when it comes to treatments and when it comes to what is best for public health, is now under attack. It is now in a weird space where some things make sense, but other things are complete and utter nonsense. But what I will say is, at some point in time, everything has to come back to normal. And when I say normal, I mean the truth is being told. We know what the answer is. And we are trusting our public officials and our public health officials, especially. So, shout out to the first HIV/AIDS peer education crew. God rest your soul, Mr. Porton. And shout out to Liz Ruffin for creating the avenue and the lane that is HIV/AIDS education, period. I thank you all. And sorry for the late show because, again, technical difficulties. iOS 26 came out. And because iOS 26 came out, computer did some weird stuff. So now that it's out of the way, thank you. And I appreciate your time, guys. So if you do not have any questions for me, or feel free to comment below, don't forget to like, subscribe, share, follow me on Facebook, Instagram, and on YouTube. Have a nice day. Be the best you. Class is Stoutt.